How you going, guys? Patrick from North Australian Heavy Mechanical. We're once again on the side of the road bashing out another episode on my days off in Dampier at the moment. So today's video is going to be a good one, and it's going to be a multi-part series. Basically, it's my approach to diagnostics and how I came to the process that I go through today. So thank you very much for the support on the last couple of videos. It has been amazing, right? Even if you don't hang around for the full video, just do me a favor, like the video, get in, leave me a constructive comment, because I love getting back to people, and share this video. If you know a tradesman or even apprentice, right, that is chasing some experience, send this video to them, because you know, I've got some really good feedback and I want to grow this. And you know, by you liking and sharing the video, you're supporting me and punching that algorithm so these videos get out there, and it really helps, right? So, and then it gives me justification and motivation to make more videos, right? So in today's episode, it's going to be a multi-part video. We're going to do a couple episodes on this because it is a massive topic. I'm going to be running through where to start with diagnostics, my approach and how I came to this conclusion, and then finding points of difference, right? And then chasing these points of difference. And then we're going to hang around for some stories, right? So the most important thing with diagnostics and the most valuable lessons you will get is where you get it wrong, right? And you make mistakes, right? Because these are the lessons that'll stick with you for the rest of your career, right? And you'll see some of the, I'm going to give you some of the stories and show you some of the videos where I've gotten it wrong. Basically, these are the best lessons, right? Because you go down a rabbit hole or two, right? These are not invaluable lessons, right? Because you go and learn a system, right? When you go down a rabbit hole, basically you get to diagnose and test things that you might necessarily have learned if you had gone down the right course. I've gone down holes where, you know, I've spent a whole shift going down a hole, and then you get to the end of that shift, and basically by staying with it, you've learned another system, but then you've found the fault, and those are lessons you never forget, right? And the way I like to approach diagnostics is elimination, right? So for example, you might have 70 components in a system. The best way to eliminate things is go through and prove what it isn't. Most of the time, hard faults, you'll never walk up, very rarely, you know, you'll walk up and just nail it. The man that knows everything already, he'll never learn a thing, right? So I approach every fault like it's new, right? So it is elimination, right? It's eliminating. You've got 72 components in a system, you eliminate 70 of them, and it gets down to the last two, and then it's a matter of going, all right, it's one of these two, how do I prove which one it is, right? So elimination, we eliminate, prove what it isn't, and then move forward. Hard faults are basically that. I've spent days and days chipping away at excavators that have a fault in them, and proving what it's not, and writing it down and having a process to go through, right? So this is going to be a good series, guys. So smash the like button. Let's get into it. All right, cheers. All right, where to start off, guys? So before we approach a system, we must understand what's in it, right? Now, when I was an apprentice working for Komatsu, right, we used to do these things when we do the new machine assembly, right? And it was called a PM clinic. And I used to think to myself, God, this is a waste of time, right? It's a brand new machine. Everything should be immaculate, right? Everything should be within spec. And you know, what was this PM clinic that we used to do? Basically, you go through, check your high and low RPM, check your servo pressures, check your main reliefs, you'd check just certain things. Like, right, it was a massive list of things that you would go through and check. You'd stall things out, check your servo pressures or your pilot pressures, check your RPMs, you know, check your fan speeds, you do this, you do that. And, you know, I just used to think, what's the point of this, you know? And they'd always on a brand new machine, you'd have to go through. And I think it's a brand new machine. This thing's come from Japan, whatever. It's just come off the boat. Why would any of these pressures be relevant, right? But also you're selling a new machine. You want to make sure that machine goes out, right? It didn't make much sense to me at the time. But then when it started to make sense to me was when we go out and you'd go to a breakdown with Komatsu, right? So where did this come into play? So you'd go out to a machine in the early days, and I would, you know, they'd say to you, well, go do your PM clinic. And I'd think to myself, well, what's a PM clinic going to tell me? Go through, and you'd sort of go down. What happened at first was I'd start to go, oh yeah, we've got slow hydraulics. It's going to be something to do with the hydraulics, right? And then, you know, you go through and you take a couple pressures, and then I'd call up tech support, and tech support would be like, okay, so yeah, Patrick, you've done the stall pressures, you've done your servo pressures, what's the RPMs on the engine? Don't know. And they go, well, Patrick, don't fucking ring us up until you've got your RPMs on the engine. What's the point of ringing us up? And I think to myself, well, why have I got to do the RPMs on the engine? Well, over time, right, I started to realise, because I got quite a few times, ring up and say, well, I've got this and going on, and they'd say, well, what's the PM clinic say? And I'd be like, oh, well, I haven't done the full PM clinic. And they're going to me, well, why are you ringing me if you haven't done the full PM clinic then, Patrick? You got to stop ringing me. If you haven't done the full PM clinic on the machine, don't ring me. And then what I started realising was, okay, I'd go through and do the full PM clinic. And when you've done the full PM clinic, right, slow hydraulics, and then a couple of times you get, oh yeah, the RPMs on the engine are not right. And then you go through and work out why it didn't have the RPMs right on the machine, and right? So I'm chasing a slow hydraulic issue, and then the RPMs weren't right on the engine. So if your RPMs aren't right on the engine, that's a point of difference. So of course the hydraulics are going to be slow. If your RPMs are not getting to the full RPM, so you're meant to have, for example, 1850 RPMs, right? And you're only getting 1600 RPMs, you can go and chase a hydraulic issue. You think it's a pump, you think it's a relief, you think it's this or you think it's that, but if the RPMs aren't right, of course that's never going to be right. The flow coming out of your pump is never going to be right? Your pressures might be all right, but the flow coming out of the pump's not going to be right. So this is where going through and having a process when you approach an excavator that has a performance issue, you have a process that you go through, right, and you don't skip on this, right? You make sure that engine is making horsepower. Because if you don't, then you can go do your cycle times right, and if your engine RPMs aren't right, the cycle times are naturally going to be down, because that's a symptom of low RPMs, right? If your RPMs are down, that pump's not going to be spinning as fast. So yes, you're going to get your stall pressures right, but your flow is going to be wrong out of your pump because it's not spinning fast enough. So this is a point of difference. And what I started to realise when I rang up and got abused a couple of times from technical support saying, Patrick, don't ring me up unless you've done all the checks, right, was I started to realise that you start to find a point of difference. So I'd start to do the full test, right? Oh, well, my RPMs aren't right, so I've got to go and correct that before I go and ring technical support. And then I'd correct the RPMs, and then boom, next thing you know, the digger starts working correctly. And then I started realising, oh, okay, so there's a reason why we go through and do the full PM clinic. And then once I left Komatsu, then I started to realise as well too with other machines, okay, what can I test? What can I test? What can I test? So points of difference, we need to find them, and you need to have a clear process. So this leads into my process now, right? Experience, you can skip a few things with experience, all right? So the next step is experience, what experience teaches you. So points of difference, right? What is the point of difference? So it's quite simple, really. So we go to a machine that's excavated, that's down on power, right? First thing you can do, low RPMs. Is my engine making horsepower? If that engine's making horsepower, or not making horsepower, sorry, from the get-go, if that engine is meant to be at 1850 and for whatever reason it's at 1750 and it's struggling to make horsepower, there is no point going and checking a cycle time until you correct that point of difference, because of course your cycle times are going to be down because your RPMs are down, right? Simple. So a slow cycle time, we've got 1850 RPM, stalls are good. Cycle times, you've got two engines, one cycle time's faster than the other. You've eliminated one engine, you don't need to look at that engine, right? Then stall pressures, are my stall pressures low? If you've got a stall pressure that's slow, then that's a point of difference. We go and chase that pressure loss. Servo or pilot pressures, are they low? That's a point of difference. If they're low, then there's no point doing a cycle time, because the cycle times are going to be down because they use servo pressure to regulate the pumps. Simple, right? So you go do cycle times and your servo pressures are low. Oh fuck, I've got a slow implement. What's it going to be? If your servo pressures aren't correct, then your cycle times are going to be slow, right? It's a point of difference. So a drifting implement, that's a point of difference. You've got a pressure loss. One implement that's slower than the others, right? That's a point of difference. Have I got a soft stop that's engaged? That's a point of difference that you can chase. So we're looking for horsepower first, flow, pressure loss, servo, right? So always chase your points of difference, right? And this is, it comes back to the PM clinic, right? That's basically a tune. you're tuning the machine. And this is how they go about tuning a machine, right? You go and have a look at your tunes. Most of the time, it will be start with your horsepowers, then you go your servo pressures, then they go and back their main reliefs off and they do their cut-offs, right? So your pumps are cutting off all at the same time. And then you go through, you set your main relief, you wind your main reliefs up, and then you go and flow your secondaries, because if you flow those secondaries before you set your pump cut-offs, like, you go and flow your pumps, right? Of course they're going to be out. They're going to be, if you've got pumps that are underperforming, right, and you haven't tuned your pumps and done your flows off your pumps yet, you know, you always tune your pumps first, because if you go and do those, go and set those secondaries, the pumps are going to be putting out a different amount of flow, right? And then those secondaries are going to be cracking off different, right? So there's a reason for these processes, right? And that all started with the PM clinic for me. And basically, it's always start with your horsepower, then you go servos, then you go to your pumps, you tune your pumps, then you move on to your secondary reliefs, and then you go and back them down, back your main reliefs down. Because there's a process, right? And through the PM clinic, I basically realised that most of the time, if you go through and do a PM clinic, you're going to find a point of difference, and that's what you're going to be chasing, right? You never move forward until, if you find a point of difference, right, you think, oh, this machine's down on power, oh yeah, the servo pressure's down 10 bar, that won't be it, or one engine has a lower servo than the other. Do not move forward until you've rectified that point of difference, because 9 times out of 10, you rectify that point of difference, you're going to find that that machine starts working correctly, right? So points of difference, that's what we're looking for, and we find a point of difference, we rectify it, and then we move forward. That might necessarily be the issue, but it's a point of difference and you need to rectify it before moving forward. For example, with a swing circuit, a point of difference will be, you know, oh yeah, I've got the, my high side, right, is only 320 bar, and then your low side's doing a fluctuation, right? And then you think, oh, I'm going to go and adjust my limiting valve, because my limiting pressures, that's what dictates my maximum pressure, right? But if you see the low side fluctuating, you can go and adjust that limiting pressure all day. And if you've got a charge issue on that slew circuit, the limiting pressure, it's not going to matter. It's going to be fine, right? It's going to be the low side, because the charge oil is not keeping up to it, so the suction side can't get enough oil to make pressure. So you've got to rectify that point of difference before you move forward. Yes, the limiting pressures may be wrong, but if you've got a charge issue, you can't move forward, because that bottom, the low side is as important as the high side, right? So this is where points of difference come into play. So understanding how to, so basically I recommend the PM clinic. Yes, it is boring and it's basic, but it's super important to learn that the process of going to an excavator that is down on power, because I see people all the time, they go, oh, you know, for example, you know, oh, we've got slow cycle times on one engine and the fuel rate's down. Okay, yeah, the fuel rate's lower on this one. Like, well, why is the fuel rate lower? Is it the fact that one of those pumps is not stroking up? And yeah, of course, naturally the engine's going to use more fuel, use less fuel, because it hasn't got as much load on it. Or is it the fuel filters that are blocked, right? They get so fixated on the one thing that they find that they ignore everything else and ignore why that machine would have a low fuel rate. So you've got to start thinking, don't look at the low fuel rate, look at what causes it, right? It could be fuel filters, it could be the fact that one of those pumps is not stroking up and putting enough load on the engine, right? So points of difference are very important. That's where understanding, I always recommend to people, understand how to tune an excavator. I'm not a fucking tune king. I'd probably necessarily, at times I've gone through and tuned them, but very roughly, tuning is one of those things that you need to be doing all the time, and that's all you do to be good at it, right? But understanding the process of tuning an excavator is super important, especially when it comes to it being stuck on the bench, right? I know plenty of guys that won't be able to tune an excavator from woe to go, but they understand the principles, right? What creates flow and what creates pressure? What do you need to make this recipe, right? So next we're going to dive into some of the areas where I've got it wrong and learnt some valuable lessons from it. So hang about, let's go. So some of my stuff ups, and some of these are recent. Slew faults always seem to, be one of those ones where it's difficult, especially with closed loop. So had a 996 basically that ruptured a pump, main pump, sent a heap of metal through a circuit. Then we basically went through and semi-flushed that circuit, then basically replaced the rear swing motors, and then this fault went on for quite a while with underperforming slew that they were complaining about. Basically, there's quite a few people involved, so you know, everyone's having their ideas and we're changing things out constantly. And then it got to the point where it was a couple of boys went on break, and then it was just myself, and then I basically went and did what I wanted to do. So we had a low stall pressure one way and a higher one the other way. So you'd slew, I think it's to the right pressure was higher than the left one, point of difference, right? And then basically I just went through, switched the secondaries, no change, and then that was when I went up to the front of the machine. Recently we replaced the front slew motors. Recently replaced the rear ones, like very recently. They're pretty much brand new. The front ones were very low hour. Went through, cased those motors that night, towards the end of the night. I was fairly cooked after doing that, and I thought it was excessive case, but basically when you're casing two motors side by side, what I like to do is go low RPMs, get two 20-litre drums, case it for 30 seconds and compare. And I was like, that seems an excessive amount of case. And I was like, but these are only, you know, 2,000-3,000 hours old. Handed it over to the boys, and I thought to myself, I should have cased those rear ones because they're brand new. Anyway, boys the next day come in and say, yeah, front slew motors are casing hard. You know, we've got to get some motors for it. Okay, so then we put the new motors in it. It got better. Only got better for a couple of hours, and then turned out to be the Power Pack 2's pump right as well too. So metal had gone through everything again, smoked that rear pump again. So basically what I'd learned from that is always go through, like if you don't think it is, and you've got a new component there, for example motors, you've got a brand new set of motors there, case them and compare them to the front ones, because I was there but I just didn't go and do that extra bit because it was the end of the night. And you know, it was one of those things. I learned a massive lesson from that slew fault because it went on for about 2 weeks. Really taught me about closed loop slew. There was a lot of boys involved with it. There was a couple good boys there in the end that just soldiered on, because it was one of those soul crushing jobs there towards the end. But we got there in the end, right? But we found points of difference, and then you leverage those points of difference, compare, test, move forward, never get disheartened, just keep testing and eliminating. Next was a O&K shovel. Hadn't had much to do with sill faults. Basically at the start of the shift they said, oh yeah, you're good to go. Went to go slew it, wouldn't slew. I'd had nothing to do with sill before this because I just dealt with the old O&Ks that don't have the sill system on it. Straight away was like, oh well, they replaced the sill valve. I don't know much about the sill system. Went and pulled the sill valve out, looked at it, looked good. Basically it was just like, well, it looks good, it's working, activated it. So then we went down the path of, why is the controller not releasing the swing brake? That was a symptom. It won't release the swing brake if the pressures aren't right, because they have transducers on each of these sill valves. Earlier in the day, I'd noticed at our balance valves, one of the balance valves had a pressure difference than the other ones. And I was like, why is that pressure different? Wonder if that'd have anything to do with it. Nah, surely not. So then we had a controller. We thought it was a controller, swapped the controller out, and was like, exact same thing, still wouldn't release the brake. Getting towards the end of the day, I'm like, we have a pressure difference, we have a point of difference. I'm gonna rectify this pressure difference. Then what I did was went down and disconnected one of the other sill valves. Boom, then that sill dropped out that balance valve. And I was like, oh shit. So it's gotta be that new sill valve. And so we spent a good 8 hours chasing a swing brake release fault. Why it wouldn't release the swing brake release? Because it didn't have the right pressures. So point of difference, I should have rectified that earlier, right? Again, this was a 996. We were getting we were getting a stick out fault. This was the one that I found the connector that was loose. Basically, we switched the FSG board out. Luckily, these sites carry these sort of things. But we switched the $6,000 FSG board out for the fun of it. Still the same fault, and turned out to be that loose connector, right? Sometimes that is part of the process. If you do have a spare one there was no harm in it. Basically we had a spare one, put it in there. But again, if you're in a remote situation and you call an FSG board and it's a $6,000 to $8,000 component, it's quite embarrassing, right? So always find a point of difference and, you know, understand how things work. That was one of the ones where it was like, I went through and studied the circuit and said to myself, well, yeah, the way it's wired up, it can still drop the lights out and not be the FSG board. And I learned a lot from that. So then when in the future, I went through it and understood the circuit. This is where understanding circuits and how things work is super important, right? Again, this was an O&K shovel, high slew temps. We were getting high slew temps. Basically, I went through with my temp gun and found one of the pumps was casing excessively, was getting hot, and then there was slew motors getting hot as well too. And then I checked the charge pressures and I thought to myself that night, well, the charge pressures are down low at 32 bar, they should be 35, right? And I'm thinking, oh, well, that motor's casing excessively harder than the other ones. It's got to be that motor. There's no point adjusting the charge pressures because we've got an excessively casing motor, so we're just compensating a pressure loss. But again, I then went away, thought about that one and was like, no, I'm going to adjust these charge pressures. Went back down, adjusted the charge pressures, boom, machine started working perfectly. That pump stopped getting hot. If you don't have the correct charge pressures, yeah, you are going to get excessively casing pumps. One might be, you know, slightly worn more than the others, so it's casing harder and it's going to. So always rectify your charge pressures before moving forward. And it's having that process of knowing how something works and how you tune something. With a slew circuit, you always start with your charge pressures, because if your charge pressures aren't correct, nothing else is going to be correct, right? Again, an O&K shovel, oil differential pressure from the eliminator, inlet and outlet pressures were coming up on the screen. I didn't have the insight the first time I went down to it. Changed the filters, cut the filters, inspected them to make sure there wasn't, because, you know, you're getting a differential pressure. Engine can have a pressure loss. What causes a pressure loss? You're going to be wearing, you're going to have material wearing and things. So I cut the filters, went down to it again later that night. After that as well too, that point I'd checked the inlet and out pressures and I was like, these are exactly the same. But then again, went down to that machine because I knew it'd come back to me later that night. Had the insight with me, compared the inlet and outlet pressure on the left-hand engine and then compared it to the right-hand engine. The right-hand engine was bang on the same with the pressures. Left-hand engine, inlet and outlet pressures were different. So I was like, well, the eliminator's doing what it needs to be doing. It's doing the correct rotations. I'm just going to switch these transducers and see if the problem switches. Boom, switch the transducers and the problem switched. Boom, transducers were US, right? So finding points of difference, not always getting things right. I still get things wrong to this day all the time, but that's how you learn, right? You go, understand how a system works, learn how to read schematics, learn the basic principles. Horsepower, flow, resistance to flow equals pressure, and then make sure you have all your pressures and all your things are correct before you go moving forward. So most of the time when I go to an excavator that's underperforming, I always start out with drift because it's just so easy, right? You can do it from the cab. Check drift. If I've got a drifting implement, because 9 times out of 10, that's the most common thing, right? It's going to be a secondary. Then I go cycle times, single engine cycle times if you've got that. Then I go to stalls and servos, and usually servos you can just check at a glance, right? Whether it's a Liebherr, you can check it on the grease controller, but it's always good to go through and confirm. So having your own process that I've built up from my experience, where it's most likely going to be, then moving through like the PM clinic, right? Moving through what's the most likely, you know, it's so easy. Like most of the time you can get in the cab of an excavator, check your RPMs, make sure when you're going down there, you're looking at that digger coming off the bench and you're going, oh, is that thing blowing smoke out of one stack? Oh yeah, it's got white smoke coming out of one of the stacks, I'll start there. Or it's got black smoke bellowing out excessively out of all of them. So you know, no point going and checking anything else until you go and rectify the horsepower issue, because if it's blowing excessively black smoke and you go through, do your cycle times, of course the cycle times are going to be down because you're not making horsepower, right? So this is where learning to, you know, you don't necessarily need to know how to tune an excavator from in and out, but you need to understand the process, right? And that was where the PM clinics, where it all started for me back in the day, was learning how to do a PM clinic on a brand new machine. Why do we do that? Because that's the process. When you go to an excavator that's down on power, you go get all your results, and 9 times out of 10, when you get your results, you go through, you do everything, you're going to go, oh, that servo pressure's down. And then you're going to go, before you ring tech services, I'm going to go and investigate that servo pressure, right? And it might be as simple as just adjusting that servo pressure, or it might be a self-pressure reducing valve that's failed and you've got metal in it. I had that plenty of time with the smaller Komatsu stuff where a self-pressure reducing valve is full of metal. So you go and adjust that self-pressure reducing valve, it won't adjust for you, and then you go and pull it off because that's what it is, and you got metal in there, right? So finding points of difference, making mistakes, and then learning from your mistakes, right? I still make mistakes to this day, right? So hopefully you've enjoyed that one. I enjoyed making it. Fault finding is my favorite thing to do these days, you know. It's like one of those things that it's experience. You know, you're never going to walk out of your apprenticeship and be like an absolute gun. You're basically going to have a good understanding. The learning starts once you finish your apprenticeship. I get a lot of messages from apprentices saying, oh, you know, you're a really good tradesman. Where did you do your apprenticeship? Yeah, I did my apprenticeship with Komatsu, and I had a lot of good tradesmen around me to look up to. But the learning starts when you become a tradesman. You know, it's not the 4 years of apprenticeship that made me a good tradesman. It's the 15 years after the apprenticeship and the experience and being down there. So hopefully you've enjoyed that one. Smash the like button, share this video for me, and on to the next one. Cheers, guys.